And that's going to help us in the end, the degree. Type it in, hit the graph button and see if you can identify what the roots are. Root, zero, solution, those are all the same thing. So after you type it in, hit the graph button, and mine is a little zoomed weird. I can tell that this is not the whole graph. I have a cubic with a positive in the front, so there should be more to it. But I can tell I have a root right here. Can you guys tell that it's a double? Okay, and go to the table. So go second graph. It's actually much more accurate to look at the table for this. You want to look for x-intercepts. You want to look where the y is 0. So I have a root at -1. I can tell it's a double, but and then scroll along the table, see if you can find me another one. You guys find me another one? 11. Okay. I know it's a single because there can only be 3 of them, and there's 2 in the -1 already. Okay, now I just found all the zeros. Unfortunately, this is not factored. I could backwards factor it. This is not what I want you guys to do though. So I do know that at the very end, I'm going to have x equals -1, x equals -1, and x equals 11. I know the backward factoring of this is going to be x plus 1 squared x minus 11. I forced it backwards. This is not what I want you guys to do though. So what I want you to do is when you have a problem like this, go in the graphing calculator and get a root. And then divide. I can tell I need a 3 by box because my original problem was a cubed. And this would be x plus 1. And this would be x minus 11. Do you guys see what I did there? I took my root backwards into a factor. Okay, so let's do the x plus 1. X cubed, x squared, x squared, -10. Hey, you guys with me so far? Now I have to see if I'm done. I know I'm not done because I cheated, found the answer. This is not right. Yeah, it is. It is. Mm-hmm. Yep, you can't. Okay. Now, you use your backwards factoring as a check. Um, but a lot of the time, unfortunately, that second part is not going to be factorable and you're going to have to do quad formula anyway. So you have to know how to do it regardless. They're not all going to be nice numbers. And especially when you have a graph where like it crosses at a fraction or a weird decimal or something. This is just a baby one. Okay. Um, but I like to use it to check before I walk away from the problem, make sure that I did it correctly. Okay, so let's go over the process of what I did here. This is really, I'm already into today's lesson. I know it's a warm up, but we have not done this before. The first thing I did was I went into the graphing calculator and I got a root. You're going to say to yourself, what if I don't have a calculator, Mrs. Talbot? I'm going to have to give you a root then. And that's sort of not true. Where are my mathy students? Right. There's only four options that you could use for whole number roots in this problem. If you look at the -11 off the end, for there to be, no remainder, the only options are 1, -1, 11, and -11. Back in the day, when we were in high school, they would make us guess and check it. So we'd have like division set up. We didn't do box division. We did something called synthetic division. Um, and we would check for remainders to find a root. But because I'm a nice lady, I'm gonna let you use a graphing calculator to find it, or I'll give it to you. But anyway, so then I found roots off the graphing calculator. I chose one to divide by. So I divided, and then I got a squared. And I used my quadratic techniques to solve this, which was diamond and box or quad formula. Guess you could complete the square if you're a complete the square lover. I probably won't do that at all. Okay. Find the equation of the exponential through 2 points and asymptote. Okay, asymptote, undo it on the y's. Why do I just get the feeling this is going to come out terrible? It's not, it's good. Any questions about what I did so far? How many B's does it take? 3. You're telling me it's going to be fine. You're reassuring me that it's going to be fine. Mrs. Talbot, it's going to be fine. If you type it in your calculator correctly. Did I type it in correctly? Okay. Nah. Wait a minute. Actually, I think those were in your homework last week. There's some in the homework, weren't there? Someone asked me if you just subtract from the y. I can't remember what it was. Alrighty. You guys can set that aside. So today we're going to do two problems in a Kahoot. Uh, the Kahoot is about finding the degree. It asks you just, there's no like actual math to do on paper. It's just going to ask you questions about polynomials. So it's one where speed is of the essence. So this is one that's all about speed. But first we have to put ourselves through factoring and finding roots of polynomials. Homework is 4 problems, 112, 113, 119, 120, and the pi tells the square root of -1 to get real, and the square root of -1 tells the pi to be rational. So the pi puts himself over himself to make 1, and the square root of -1 squares himself to make -1. Hmm. Hmm. You can get that on a t-shirt. I think I have it. I did wear a math shirt. It says math, the only subject that counts. Miss Rice and I have the same shirt on, but we can't figure out what to do for tomorrow. I can't. It's too hard. They made me think. Yeah. So like you're supposed to have another person and you're supposed to find 2 words that rhyme with each other, but like don't go together, and then you each dress as one of those. Yeah, I don't know. Once it like required me to use my brain, I was just like, well, I think I have all the other days covered. Grace told me that I could Google it, and there are a lot of examples on the internet. To figure out what to wear for a spirit day? Yeah, that could be good. That's if you can help me with my phone suit. Okay, all right. Anyway, okay. So when you guys are done writing this, put this in the graphing calculator, please, and find me roots. Then we probably get all 4 from the graphing calculator. You might, probably not. See what you can get from the graphing calculator. Are there 2 of them? Okay, great. So then write x equals 2 and x equals -1. But all of you should type it in and make sure that you see what it looks like that you get root. You can use either the table or the graph. I like to use the table because I feel like the graph lies to me sometimes. Yeah, see that one? It's like not exactly on the, yeah. Okay, you guys all with me so far? So I wrote it down. I found the degree, which tells me that I should have 4 answers at the end. I went to the graphing calculator, found a couple of them, at least gave me a place to start. Does that make sense? Okay, now I'm going to change. I'm going to start at the top here. It doesn't matter which one you start with, but I'm going to take this root and change it to a factor. And then make myself a 4/2. Tricky. It's tricky right there. Okay, you guys remember when we did the factor and remainder theorem? We made like, I gave each group one and we got, okay, so when you're doing these problems where it says to factor, you should always get no remainder. If you get a remainder, that means you did something wrong. You gotta go back up in your problem and check it. So these should always come out evenly, which is satisfying. Okay. So far I have x plus 1 x cubed minus 2x squared minus 3x plus 6 equals 0. Okay, do you guys see where this came from? Okay, now I'm going to take my other root from my graphing calculator and change it to a factor and make myself a 3/2. Oh no, what happened? I have an uneven amount of boxes. Yikes. A little bit of a spicy division problem there. So I had the side and the top, affect this one, and then factor that piece to be this and this. Now technically, I should check to see if I could diamond and box this piece, but I already know I can't because there's no V term there and it's not a perfect square. So that is factored form and that is all the way factored and it's done. Not actually done, but it's done. I mean, the factoring is done. Do you understand what to do if that had been diamond and boxable? You'd have to like diamond and box this part. Okay. All right. So I factored completely. Yay. Now find and describe all roots. X equals -1. One single real root. X equals 2. One single real root. Two single real roots. Does that jive with my picture? Can you see that that crosses the x-axis 4 separate times? And this little guy here is not a double. It really wants to look like a double, but it's not. Got it? Okay. All right. One more, then a Kahoot. And this one's just a cube. And I don't know why I left so much space. It's something special. I'm trying to walk you through this. Why is it Q of X? I don't know. First, type it in the graphing calculator. Find roots. Step 1, graphing calculator. And this one's going to give me some bad news right off the start. Just looking at the picture, can you give me the description of the roots already? One single real root. Yeah, two single complex roots. Oh no, that implies that we're going to have to use our best friend, the quad formula. Yay! Okay, but anyway, we got the x equals 1 correct. And that is the factor x minus what? Everybody clear about where I got this from? Okay, I'm gonna set myself up a 3 by 2. Maybe we can use this problem to test our conjecture about where the bump is. So let's say I didn't look at the graph and realize that there are going to be eyes in my answer. I would try the diamond and box. It does not work. And you don't need to erase it. It's fine. You checked. That's good. Oh, by the way, if this doesn't work, this means that this is factored form. It's done factoring. This is not factorable anymore. So that's it. Don't put it in reverse quad formula. Like, don't put x minus the roots of quad formula. I could not get my son to stop doing that. I don't know why he kept doing it. This is from like 2018. I don't. Anyway, okay. So A equals 1, B equals 4, C equals 5. X equals negative B plus or minus square root B squared minus 4 AC all over 2A. Okay. Equals negative 4 plus or minus 16 minus 20. Okay, so let's take a look at this graph again just to verify. Uh, and I don't want to add insult to injury, but if you put too many bumps on your sleeve, two single complex roots is just one bump. Okay. So the one and then the two from the bump. You don't make two bumps. Also, what do you think about our conjecture so far? What is the real component of the, complex answers? -2. But Buck's kinda at -2. I think so far so good, but I don't know. I don't know if it works every time. I can't say it, but so far it's been working. Okay, can you guys prepare for Kahoot, please?